So come on, let's get down to some real Python coding and take a look at Objective 1.2, where we're going to understand Python's logics and structure. We'll be looking at keywords, instructions, indentation, and comments. Now, the first thing, of course, is the definition of a keyword, and probably you've got a good idea what we mean by that already. But this is a reserved word within the Python language, and we cannot use that word for our own variables or names or any identifiers we're trying to set up ourselves. Now, we can actually import a module. Import itself is a keyword. For the Python certified entry-level programmer, you don't need to know about modules, but they are easy enough to use. We're just bringing in additional Python code. So we import the module keyword, and then we go into that module and use a function called isKeyword, and then we can test different words to see if they are actually a keyword or not. Although this is probably not strictly necessary if you're using Jupyter Notebooks, or if you're using an IDE, because you're going to get color coding of the keyword. As we look at some common keywords, we've got the if statement, which is used to manage conditional statements. The define keyword, which starts the definition of a function, your own code that you can repeat anytime that you need. The return keyword, which is essentially part of a function and defines what the function should return to the calling program. And a while loop. We have different types of looping structures, but within a while loop, it will continue to loop whilst a condition evaluates to true. But like most of this, we can look at the slideshow all day, but getting out and working through the demonstrations with you getting hands-on experience as well is going to be most beneficial. So we're going to take a look now at working with keywords. We'll see some common keywords, and we'll import the keyword module so we can test different words just to get the feel of Python. So come on, and let's dive out to our Jupyter Notebook. I've already shown you how to set up Jupyter Notebook, so let's go through and create a new notebook, file, new, and notebook. We can select the kernel, and I'm always going to select the preferred kernel, so let's just go through and set this up. And we can go through and rename the untitled Jupyter Notebook to something more reasonable, so we can call it keywords. Jupyter Notebooks are more than adequate to help you run through your learning for your Python certified entry-level programmer. It's also relatively easy to run through, as you'll see in this demonstration. Let's set up a very simple if statement. So I can go through and have if 3 plus 5 is equal, so we're testing the equality, is equal to 8. We don't have then as a keyword. We don't need then. We just put a colon to specify that we are entering a block of code if this condition evaluates to true. As I then hit enter, you can see that we are indented. So the code we are now executing belongs to the evaluation of true for the if statement. And we can go through and print out some kind of message saying this is true or whatever we feel is appropriate. Notice that when we're printing a string, we enclose the string in quotation marks. I can use Shift and Enter to execute the code, and we're going to be able to then see if the evaluation is true. And lo and behold, 3 plus 5 does equal 8, so the condition evaluates to true. We get to print the code. But what if I changed the 8 through to 9? 3 plus 5 does not equal 9, so it won't evaluate to true. If I now hit Shift and Enter, you can see I'm not getting any output from the code, as we're only printing if the condition is true. Well, let's try something else. Let's try another keyword. We get the idea that we're using keywords. Take a look at if and def here. Here we're creating a new function. So we create a function with the define keyword or def. The keywords are highlighted in dark green in this notebook. I'm creating a function called hello. Again, all of the code associated with hello code is going to follow the colon and be indented. And we can then go through and print, and we can have our classic hello world. So rather than having to use the print statement myself, I can now go through and use hello. I'm just hitting enter twice to make sure that I'm returned to the left-hand side. So we now know my code is not associated with the hello function. As I go through now and call or invoke the function, the two words invoke and call have the same meaning. Shift and enter on the hello function, and we're going to get hello world printing out. Now, we don't need to understand too much about functions, but this is really simple, so shouldn't really struggle too much in the understanding. But we can add a little bit to this. We could change it a little bit, and instead of printing, we could return. Return itself is a keyword. Look what happens when I type return. It's highlighted in green, just as def is. So whenever we run the function now, we're going to return the value, this is the statement, to the calling program. So I can then have answer is assigned the value of. So we use a single equals for our assignment. Look in cell 2, where we're testing for equality, we use the double equals. So double equals is different to a single equals when we're talking about the syntax of our language. So we're assigning the value of hello through to the answer variable, and then we're printing out the answer variable. We don't quote answer because we don't want to print the word answer. We want to print the contents of the variable. And there we have it. This is the statement. Now, even though this has worked, it perhaps doesn't make that much sense. So a return is probably more likely to be used when we do some form of calculation. So let's have add x plus y. So we'll have two parameters, x, comma, y. We then have our colon to start our block of code, and we're going to return x plus y. So we're using the plus symbol here as our addition operator. We can go through and assign to our answer variable again. So we can have answer equals, and then we can go through to our add function and choose two numbers, so 2, 6. So we're going to add 2 and 6 together, and that's going to be populating the answer variable. We can then go through and print our answer variable. And now when we use shift and enter, we can see then that we get the 8. I know we could have done the addition ourselves, but we're looking then at a valid use of the return statement. Now, in an IDE, such as our Jupyter Notebooks, we do get the color coding to help. But if we did want to check whether something was a keyword or not, then this is where Jupyter Notebooks can be really useful, because we can run code very quickly to check something. We can import a module. And as I mentioned in the slides, we don't need to know about the import keyword or modules, not for your PCEP, but let's go through and import the module keyword. I can run this by itself, but it's available for this notebook. So I can go Shift and Enter on this. It has an error, so the keyword module is available on this system. It is part of Python. But now I can go into my keyword module and navigate the namespace and go keyword.isKeyword and test a string. So I can test the word while, which is for creating looping structures. Shift and Enter on this, and we're going to be able to see that while is a keyword. Well, okay, let's change while to something else. As we go through and edit the code, we can put in the word import. And again, we're seeing as I go Shift Enter on that, import is a keyword. Let's go through and change it to if. If is also a keyword. But okay, what about something like hello, where I've created my own function? Well, that's not a keyword, so I can use, as we can see, for my own variable name, my own function names. We've also used the word answer. Well, was I valid in using that? And as we test that, that again is false. It's not a keyword, so it's available for me to use. So in this module, we've taken a look at the definition of keywords. Keywords are reserved words in Python that have specific meanings and purposes. They are part of the language syntax and cannot be used as variable names, functions, or identifiers.